All right, our next lesson is on volume of spheres, and we can think of a sphere as being just a ball, right? It's a three-dimensional shape for a ball. It's not a circle is two-dimensional, but a sphere is a three-dimensional shape, and we can, again, think of it like a ball. All right, so a couple things. By definition, a sphere, we might call it a ball, but in geometry and math, the official definition is the set of all points in space equidistant, meaning the same distance, from the center of that shape. So it has, in two dimensions, this would be called the radius, where the circle is the same distance from the center two-dimensionally. In a sphere, it's not only two-dimensionally, but also three-dimensionally. All right, a radius then is a segment with one endpoint being the center of the sphere and the endpoint on the sphere itself. So we're going from the center to the sphere. So this, normally in a circle, we would have a radius this way or this way. In a sphere, it goes in all directions. The diameter, again, is going to be a segment that passes through the center of the sphere, right, with two endpoints on the sphere itself. So you have the sphere, and then the two endpoints are on the sphere. All right, the great circle, this is a word is kind of new. It's the intersection of a sphere and the plane containing the center of the circle, right? It's the cross-section that splits the sphere in half. So if you take a sphere, cut it in half, that's going to be the cross-sectional circle. The great circle is the biggest circle if you cut a circle in half that you could have. And that's going to be literally the diameter of the circle. If you were to cut the sphere at the diameter, you create the great circle. All right, a hemisphere then is a word we hear a lot. It's going to divide a sphere, right? It's hemi, it's part. The circumference of a sphere is going to be the great circle. So if you want to find the circumference of a given sphere, it is the circumference of the great circle. Again, that's the widest part of the circle that we're going to have in the sphere. All right, so here we have some problems here. The volume of a sphere is going to be 4/3 pi r cubed. There's a couple ways to do this depending on what calculator you have. So in this example here, they give you a diameter. So this little circle here is what we're going to call the great circle. And then if the diameter is 18, the radius is 9. We have to divide it by 2. So we do 4/3 times pi times 9 cubed. If you do that in the calculator, we prefer to leave the answer in terms of pi. So if we do this in the calculator, do not put pi in the calculator, do everything else. So 4 divided by 3 times 9 cubed, and we're going to get 972, and then we just add the pi at the end. So 972 pi would be the answer. All right, the next one, they give us a diameter of 30, which means the radius is 15. Again, type it in the formula, we get 4,500 pi. These are some very big volumes, of course, right? I mean, 30 inches, that's like a 3-foot big sphere. That's a pretty good sized ball. All right, down here, they tell us the circumference of the great circle is 13. Well, that is the circumference of the actual sphere itself. So by doing this, we find out that the radius is going to be 2.07 units. We could even round it to 2.1 if you want. I use 2.07. All right, when we do this and plug in our numbers, we get a volume of approximately 37. You may get 36 if you use the answer down to 2. It just depends when you round it. So we're going to get a volume of approximately 36 or 37 units by doing this. So here we see an example where they give you the circumference, which you need to find the radius to be able to plug it into the volume equation. Example 4, this is one example where they give you the volume itself, and then you have to now find the radius. Because in our equation, we only have two variables. We have volume and we have radius. And so there's only two ways to solve this. You can either find the volume, which we've just done a couple times, or you can find the radius. So in this problem, we have our volume, which is equal to our equation. And what we're going to do is we want that r cubed by itself. So we're going to divide everything by 4/3 pi. And when we do this in the calculator, you get 1,331. And then how do we undo a cube? Is we're going to take the cube root. And when we do that, we get a radius of 11.